Cyclic structure of glucose. See, we have already explained about the structure of glucose where we have only a straight chain. But when we check the presence of aldehyde group, the glucose does not give Schiff's tests. Let me put glucose as G. So it possesses CHO. It is expected to react with Schiff's base being an aldehyde. So SCHIFF. It was expected a positive one, but this does not react. Secondly, the glucose having the CHO does not react with the addition product. It does not form the hydrogen sulfide addition product. Hydrogen sulfide means Na sulfite, NaHSO3. No addition product. And then, so it means this CHO is not free. It is not freely available. Next one, the pentaacetate of glucose does not react with hydroxylamine, okay, indicating the absence of free CHO group. For example, any RCHO, if it is aldehyde, let me put like this, aldehyde, it will react with hydroxylamine, that is NH2OH, so that it forms water, and the water is removed and it forms oxime. So CH double bond NOH. Okay. So it means that CHO is not free. Okay. So in glucose, assuming that it has got CHO, does not react with NH2OH. It means this is not free. It's not freely available. It is bound somewhere. So it means the glucose is found to exist in two different crystalline nature. One is alpha, another is beta. So it has got two different nature, alpha and beta. Alpha form of crystal has the melting point 419 Kelvin, whereas the beta form has the melting point 423 Kelvin. So beta is higher melting than alpha. So this behavior could not be explained by the open chain structure for glucose. So it was proposed that one of the hydroxyl units would have added to the CHO group. For example, let us consider CH3, that is the aldehyde group. Let us have the free aldehyde group. Let me write like this: C double bond O H, and we have H OH, then OH H, and then H OH, and then H OH, then CH2OH, right? And probably this second, that is, if we count from here, first one, second one, third one, likewise, let us count from here: 1, second carbon atom, third, 4, 5, and this is the sixth carbon atom, right? You please note down, from the top, the third carbon atom has the hydroxyl unit group on the left side. Okay, that should be remembered. Now what happens here is this fifth hydroxyl group, that is hydroxyl group attached to the fifth carbon atom, that is this one. Okay, this fifth one would have interacted with what? The first carbon atom, like this. Are you able to follow? And forms a compound, a structure like this, that is C, and this becomes, this H will go here. Okay, so OH and H, and from the top it forms, it is called an hemiacetal ring. So it forms, okay, so first carbon atom, second carbon atom, third carbon atom, fourth carbon atom. As I already told you, fifth carbon atom would have formed a hemiacetal ring, and this is the CH2OH. So this is H, this is HOH, this is 1, 2, 3, fourth one. From here, third one, that is OH, H, H, OH. Do you understand the structure? So this forms a hemiacetal ring like this, and it can form another structure, that is this OH can be present on the left side. So let me write down the structure once again. I can put CH2OH here, and here you have the C. Now OH is on the left side, and here on the right side. So first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom. Now there is a hemiacetal ring formation with the fifth carbon atom. So H, and this OH is involved in the hemiacetal ring. So you have H, OH, and from here OH, H, and then H, OH. So 1, 2, 3, 4, 5, 6. Got it? And this is called, that is, in this case, the OH on the right side, and here the OH on the left side. So when the OH is, that is the first carbon atom OH is on the right side, it is called alpha glucose, and this is called beta glucose. Are you able to follow? So how it should be named? Beta D and then plus. So you can put alpha beta D plus glucose. Okay, what about this? Alpha D plus glucose. So likewise, we are able to get the two forms of, that is two cyclic hemiacetal forms. And this cyclic hemiacetal, and the top one is called the anomer. It is called the anomeric carbon. Which one? The first carbon that involves in the hemiacetal ring formation. So this carbon, this is called, similarly, this is this one. Okay, they are called, that is anomeric carbon. Okay, please take down anomeric carbon. Similarly, anomeric carbon that involves in the hemiacetal ring structure. So it is proved that it is not an open structure, and these two structures, that is this alpha and beta forms, are called anomers. They are called anomers. Okay, and since it involves 6 members, for example 1, 2, 3, 4, 5, 6, is it not? 1, 2, 3, 4, 5, and this is 6. 6 is heteroatom, oxygen. It is a 6-membered ring, and that is why it's called pyranose structure. Okay, this is known as pyranose structure, and that's why we can have the 6-membered ring also. I will try to draw that structure, because pyran means it is a 6-membered ring, that is with the 5 carbon atom and 1 oxygen atom. Okay, it is an heterocyclic compound. We have the structure called pyran. This is okay. This compound is called pyran, right? And we have got another structure that is known as furan. So furan, pyran is, and there is an heteroatom. In both the cases, oxygen is the heteroatom. Take down. Hetero means a different, and here also oxygen, a heteroatom. So this is a 6-membered ring. Heterocyclic. Heterocyclic compound. This is 5-membered heterocyclic compound. And the glucose, which is having the structure similar to 6-membered ring, can be called pyranose. The glucose, the sugar unit, which is having the furan-like structure with 5-membered ring, is called furanose. So fructose will be having the furanose structure. It is a 5-membered one. Whereas glucose is a 6-membered ring. We will be discussing under furan about furanose. And this is glucose, so glucopyranose. Are you able to follow? Now let me explain about glucose pyranose. Now what I am going to do is, we have got the structure like this, is it not? You do one thing, simply you can rotate like this so that you can have this structure. Okay, now what you do is you simply rotate like this. Okay, and based on that we can draw. For example, 1, 2, 3, 4, 5, and then 6th member. So you can write like this. you can put oxygen here. Okay, and this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and you can write down the sixth carbon here. Done. And this is HOH, second carbon, HOH, and what about third carbon? OH, H, fourth carbon, HOH. That is, all the right hand OH are written on the bottom, at the bottom, and left hand OH is at the top. So this is the way you can draw the structure. And here it is called alpha D plus glucopyranose. Are you able to follow? So this is the complete nomenclature of glucose. Yes. Okay. So here let me count the number of carbon atoms also. So this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon. Now you got the sixth carbon outside the ring. And now you can find here, now look at this, this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. So there is a link between first carbon and the fifth carbon. And the hemiacetal is formed between first carbon and the fifth carbon. So this is the hemiacetal ring. Okay. So this part is called, similarly that part is called hemiacetal ring. HAR. Okay. So that is this one, and similarly this one. Okay. So here this is the hemiacetal ring. Okay, hemiacetal cyclic structure or ring you can put. Okay, and we can draw the beta also. How you can draw the structure of beta? Similar to this. Okay, draw a hexagon like this. Now first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and then H. Instead of writing HOH like this, here it becomes OHH. Is it not? And that is the anomeric carbon. Okay, so you can mention that one also. It is the anomeric carbon. Done. And now since this OH is on the at the bottom, this is alpha. Now the OH on the top, it's called beta. So H, OH, OH, H, H, OH, and then CH2, OH, and then H. Now you can find that is first carbon, second carbon, third, fourth, fifth, sixth. Done. So this can be written as alpha beta D plus glucopyranose. Are you able to follow this? Okay.